Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. In this video, we want to take a look at the definition of the derivative at a much deeper level to see how we can generate derivatives for some other common functions we've encountered before in precalculus. But in order to do so, we'll need to have a basic understanding of a few special limits that are worth remembering. We have displayed these three special limits on the screen here. We're not going to actually go into the proof of these statements because it's actually way too long and not suited for the purpose of this video. So we're going to rely on technology to get an intuitive understanding of it. Before we get started, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. We're going to use Desmos to plot the first function. So we're going to say our function f of x is e to the power of x minus 1. And then we have that over x. And all we did so far is just replace the h with x. So now the limit is as x approaches 0. So we can see that when x is 0, it is undefined because we're dividing by 0. However, we can see that the limit, so if we zoom in, we can see that it is approaching 1 as x approaches 0. Now a similar process can be done with the two other limits, the sine limit and the cosine limit. So I encourage you to graph these two functions yourself and verify the limits. We'll actually show that these limits are true and work with them even further in a later video. But for now, we'll take them as facts and use them in the next couple of examples. So our first example is to find the derivative of e to the x using the definition of the derivative. From the definition, we know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So now our function here is e to the x, so we're going to go ahead and substitute that in. So this is limit as h approaches 0 of, this is going to be e to the power of x plus h minus e to the x over h. And now we can use our exponent rule to rewrite e to the x plus h. So this is going to be the limit as h approaches 0 of, we have e to the x times e to the h minus e to the x. And then we have this is over h. And now we can factor out an e to the x from both terms on top. So this is limit as h approaches 0 of e to the x times e to the h minus 1 over h. And now, since our limit is h approaching 0 and e to the x doesn't depend on h, we can actually go ahead and move it in front of our limit. So that means we can rewrite this as this is equal to e to the x times limit as h goes to 0 of e to the h minus 1 over h. Now this is that first special limit that we listed above. And we know that this is equal to 1. So therefore, this is e to the x times 1, which means f prime of x is equal to e to the x. So this is actually really interesting because the derivative of e to the x is actually just itself. And you're going to be seeing this a lot in future videos. For our next example, we want to find the derivative of sine x using the definition of the derivative. So same thing. So this time our function f of x is equal to sine x. And we want to find f prime of x. So that is going to be equal to the limit as h approaches 0 of, we will have f of x plus h, so that's going to be sine of x plus h minus sine x over h. Now to expand sine of x plus h, we're going to be using our sum and difference identity. So we get this is equal to the limit as h approaches 0 of, the sum identity is going to give us sine of x times cosine of h plus cosine x times sine h. And then we subtract our sine x, and then we have this is over h. Okay, so we're actually going to now group this term and this term together, and then we're going to leave this as a separate fraction. So let's go ahead and rewrite that. This is limit as h approaches 0 of, going to be putting a big bracket. So we get sine x cosine h minus sine x over h. So that's our first fraction. And then we have plus cosine x sine h over h. Now the reason we want to do this is now we can go ahead and factor out a sine x from both of those terms. And because sine x doesn't depend on h, we can go ahead and pull that out in front of our limit. And similarly, cos x also doesn't have any h in it, so that can also go outside of the limit. So then this ends up being sine x times the limit as h approaches 0 of, and the first fraction is going to be cosine h minus 1 over h. And then our second one is going to be plus. We're going to pull our cos x out in front, multiplied by the limit as h approaches 0 of, and then we're going to have sine h over h. So now these are the other two limits that we have shown at the beginning of the video. We know that the cosine limit here goes to 0, and we know that the sine limit here goes to 1. So therefore, our final answer here is f prime of x is equal to cos x. And now let's do a quick recap of what we covered in this video. We learned that the derivative definition is the source of all differentiation rules. However, in order to find the derivative, sometimes it requires some special limits that we're going to need to go into further detail in the near future. But for now, you can memorize these 3 special limits for future reference. And now it is your turn to give this a try. Can you find the derivative of cos x using the definition? Make sure to refer back to these special limits at the beginning of the video. And once you've figured it out, leave your answer in the comments below and let us know what other calculus topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.